Okay, so in order to find what percent of the budget is spent on the car, you are going to have to use part over whole equals percent over 100. Zoom that in so you can see it. Okay. I'll give you all a minute to work on that. Okay. What is my part, Reese? All right, if we're not done with this, we shouldn't be chit-chatting right now. Okay, but clearly not everyone at your table does. So, okay. All right, what is my part? Anybody? 250 is the part. What is the whole?
1,000.
How much? 2,000. Because my whole budget is $2,000. And then we have 100 here, and my unknown. Is there a nice, pretty scale factor?
Yes. 100 times 20 is 2,000.
Okay, there is. How can I work this if there's not a nice, pretty scale factor? Butterfly. So I would have 2,000 times x equals 250 times 100. So we're just going to add our two zeros. Okay. Now they're big numbers, but it's still just a one-step equation. How do I solve that? Draw the line. Okay. What do I do next? What's that?
2,000.
Okay, divide by 2,000. How many of you know the trick with zeros when you're dividing?
You take the what?
Okay, Hannah.
You can, just the way I did, you can take away the zeros and just divide the two numbers and then put the zeros back.
Okay. Hannah, actually, if that's a good way to do it. But if they both share the same number of zeros, you don't have to put them back in. So we're going to take away those two because they share those zeros. They share the 10 zeros. They share the 100 zeros. And now we have 25 divided by 2. What is 25 divided by 2? 12.5. Is that my answer?
Yes.
So what percent of students made an A? 12.5%. So it's 12.5%. There you go. Does that make sense? Okay. All right. Here's the next thing. What kind of graph is this? How do we know it's not a bar graph? How do we know it's not a bar graph, Finley?
Because there's like not all the numbers.
Okay. There's not a bar for every value. Each bar has a range that goes with it.
Can you zoom it out? It's way too blurry.
Okay. Let's see if this helps. Whoa! Does that help? Alright. Eyes here, gentlemen. Okay, what percent of students made an A? Now, anytime you see a histogram or a bar graph, there's something I want you to do first, for the very first thing. I want you to look at each of your bars and figure out what goes at the end of each bar. How many students made it 51 to 60? How many made it 61 to 70? 9. How many made it 71 to 80? 81 to 90. And 91 to 100. Okay, anybody tell me what I can do when I figure out those numbers?
Yes.
What can I do, Ethan? Reese, that is not okay. With those numbers, what can I figure out pretty easily? Okay, ready? I can figure out my total. Right? I can figure out my total. What's the total number of students surveyed? So if I'm looking for a percentage, I'm still going to use part over whole equals percent over 100. What's my total? Okay, 25. 6 plus 4 is 10, plus 2 is 12, plus 4 is 16, plus 9 is 25. If I want to know what percent made A's, what's my part? How many students made A's? 4. Percent over 100, unknown over 100. Is there a nice pretty scale factor here?
Yes.
What is it? Times 4. What percentage of my students made A's?
16%.
Make sense? Alright. Next thing. What kind of graph is this? Bar graph. Why is it not a histogram?
Because it has a number or it has a bar for each.
Bar for each value. Okay. What's the first thing you're going to do with any bar graph or histogram?
Put the label. Yeah.
I'm going to label what number goes at the end. How many people liked red?
10.
How many people like blue?
20.
Green?
5.
Yellow?
15.
Indigo?
40.
It's a good color. Alright. Alright, ready? Which colors, pay attention, this is kind of a tricky one. Which colors are 50% of my data? Now, I'm still dealing with percent. I'm still going to use part over whole equals percent over 100. Do I know my whole? Or can I figure it out? What is it? Be all of them. So 10 plus 20
30.
plus 15. 30 plus 15 is plus 5
50.
plus 40, 90. Okay, do I know my percentage?
Oh, wait, no.
It tells me right here, 50%. And I need to know what number is 50% of 90. Is there a nice pretty scale factor? Okay, how do I get there? Don't multiply by 2. Divide by 2. Ready? Hang on. Dividing by 2 is the same thing as multiplying by
4. No. It's
reciprocal, which is what?
-2.
What's the reciprocal of 2 over 1?
Oh, 1/2.
What's 90 times 1/2?
45.
So x equals 45. What I need to know is which colors will get me 45. And I'm going to tell you there are two, I'm going to cheat and tell you there are two different combinations that will get you there. See what you can figure out real quickly. Indigo and green will give me 45, right? What's red plus blue? Plus yellow. So either of those combinations will give you 50% of the data. Does that make sense? Okay. This is a frequency table. Here's a question I've had a whole lot of.
Okay, wait. I was about to say my name. I said, are you?
No, nobody's asking me about you, Reese. Okay. Relative frequency, everybody needs to pay attention. Relative frequency generally means the fraction that goes with it. Okay, so what I need to know is, if I'm making fraction here, what's my part for 11 years old? This is the age of students, by the way. I forgot to write that down.
Okay, wait, what?
Student,
Part would be 5. You know,
the part would be 5. How about for 12 years old?
11.
How about for 13 years old?
4.
What's the whole?
Wait.
5 plus 4 is
Oh, wait, no.
9 plus 11. So 5 out of 20. 11 out of 20. 4 out of 20. The question is, which age represents 20% of my data? Do I know any percents yet?
So it'd be a 5. So 13.
Could I find the percent for all of these?
Yes.
Okay, let's set it up. Equals x over 100. Equals x over 100 equals x over 100.
Oh,
Is there a nice pretty scale factor?
yes.
What is it?
5.
5 times 5 is?
25.
11 times 5 is? 4 times 5 is? Which age range represents 20% of my population? 13. So 13 years old is 20% of my population. Okay, pay attention. Because this is a little strange, but you are going to see a graph that looks like this. 0, 10, 20, 30, 50, 60, 70, 80, 90, and 100. This is a percent stat graph. It's kind of strange, but here's how it works. Okay? My 11-year-olds are what percent of my data?
25.
So I'm going to find 25%, and I'm going to do 11-year-olds. Does that make sense? Now, here's where it gets weird. What percent of my data are 12 years old? So instead of starting a new bar, I'm going to add 55 onto 25. What's 55 plus 25? So I'm going to put a bar right here and say that everything in here, in this section, is my 12 years old, 12-year-olds.
Dang, it goes to 20.
Okay, which leaves only my 13-year-olds. Let's check that. What percent is my 13-year-olds? Is 80 to 100?
That's a lot easier than
Okay, now,
it just fills in like that.
you're going to see this kind of thing on your test. I always thought it was strange. If you like it, awesome. If not, that's okay too.